now let's start looking at each one of these layers in a slightly more detail. And let's start off with the specification and the support layer. Okay. Now, as you can see, the foundation layer of the backend network relies on the specification support, which is pretty obvious, by the way, right? So which comprises of 5 components, namely a set of API specifications, which define the messaging APIs, the various events that happen in a typical commerce transaction. There is a schema, which is the data standards, right? And the which actually define the message packets, the structure of the message packets inside the communication. There's a communication protocol to be implemented by any platform. There are various rules of communication for each of these APIs. It's not just implementing these APIs and just calling them. But yeah, there is a particular communication protocol which depends upon every API and that has to be implemented by any platform wanting to be part of this open network. And then to aid the implementation of these APIs, there are various reference implementations contributed by a network of volunteers comprising of independent software developers, dedicated teams of various firms and subject matter experts, etc. An open developer community has also been set up on Slack and GitHub to exchange ideas, discuss issues, and help other developers across the globe to implement these specifications. Occasionally, these communities also conduct bi-weekly calls. There are hackathons, there are business hackathons, schema building exercises, right? And apart from that, there's a lot of supporting documentation in the form of drafts, RFCs, concept papers, and example code to support the implementation of the network. Going further, the support layer also comprises of various tools and utilities like sandboxes, test suites, and certificate signing request software, etc., to aid the community to make their systems more robust, more secure, compliant, and trustworthy with various network rules and policies. Okay. Now, just to give you a snapshot, each of the API specification that you saw, the API specification component in the specification layer comprises of these 8 to 10 APIs, okay, 8 to 10 asynchronous APIs, which emulate a typical order funnel, okay, from search to confirm to track to rating. Okay, we will come back to these APIs when we go ahead, but otherwise, just to give you just a feel of what exactly backend APIs look like, every typical commerce transaction, okay, consists of 4 stages. Okay, consists of discovery, consists of ordering, consists of fulfillment, and post-fulfillment. Discovery is the stage where you are actually trying to search for items. You are trying to browse catalogs, where you're trying to search by what you want, what exactly based on what item you want, or based on categories, or even the purpose for which you are actually searching for. Okay, that's the discovery, and that discovery is implemented using a bunch of APIs, which is the search API. Then there is an ordering stage where you're actually, once you've discovered the items you've had, you actually select the items you want, you add them to your cart, and then you add your shipping details, your billing details, etc., and you receive your payment terms, your fulfillment terms, exactly how the seller wants to be paid. And then there's the actual confirmation of the order. Now, beyond order, once the order gets confirmed, we have the fulfillment stage where you are actually where the seller is actually fulfilling the order. Okay, so that comprises of a bunch of APIs which allow you to track your order, modify your order, cancel your order, and also frequently check the statuses of your order. Okay, and then after the fulfillment, you have post-fulfillment APIs, which basically allow you to rate the various elements in the order, and then also contact support. Okay. Now, one very interesting thing about these APIs is that they are all async APIs, which means that your request or your response to your request does not come back in the same session. The request is immediately succeeded by an acknowledgement saying that, hey, I have received your request. Okay, let me call you back. Now, once you have sent your request, the actual response gets returned in a separate callback API, that's why you will see that every API on the left, okay, has a corresponding callback API on the right. Okay, so one other thing which you need to know about these APIs is that these are not just async APIs, but these are also server-to-server APIs, which means that you have completely decoupled the implementation or the application or the experience layer of the of any application with the transaction layer. So these APIs only emulate transactions. The experience can be whatever you want. When I say experience can be whatever you want, we mean that I mean to say that if you're searching for, say, a packet of biscuits, it might result in multiple search calls. It might even result in a pre-booking of a delivery agent, right? It might result in confirm API calls or ordering calls at the back end. But at the front end, the user might be completely unaware of what is actually going on in the back end. Right? So which means these are all network level APIs and transaction APIs which happen at the server side. Okay. So this is one last point which I wanted to add was these APIs don't necessarily need to be called in order, right? As they're all very stateless APIs. I mean, there are use cases where you actually don't even need to call discovery or discovery API. You can directly call the confirm API without even going through a discovery API or or the order APIs. Okay. So we'll actually go deeper into each of these APIs in further sessions. Okay, so this was the API part. Okay, then we have a schema. Okay, we have a standard schema. So as you can see that there are various levels of schema which are specified inside backend protocol. Okay, there are top level schema which basically describe the various structure of various events which happen, like for example, ordering, tracking, discovering, intent, ordering, tracking, support, fulfillment, etc. Okay, these are the top level schema which describe various events. Then we have some mid-level schema which are sort of domain agnostic objects which describe various entities which exist inside a typical commerce transaction. Then we have primitive schema, like things like location, you have descriptors, you have person, etc. These schemas actually also describe very fundamental objects which are typically used inside every commerce. I mean, if you look at the primitive schema, this actually might even be as generic as to be also outside commerce, right? Location, person, and descriptor, etc. are not very specific to commerce. But if you just go up a little bit in mid-level schema, you might see things which are getting a little more commerce specific, right? And then at the bottom, we have the primitive data types like strings and integers and boolean, etc. Okay, that's something which we all know about. And there are some standards and formats like like we have IETF standards, we have JSON schema, open APIs, etc., which sort of describe which sort of use common conventions and common standards for people to understand the specifications more easier. Okay. So till now we were talking about very generic, very commerce, I would say industry agnostic specifications, right? Now it is obvious that all use cases cannot be represented using just abstracted objects. There has to be some domain level context to each of these objects to define the actual function of these objects. To make things a little more real, let me give you an example. Okay, there is a if you looked at the previous slide, okay, there is a schema called agent, or there's a schema, I don't know. Yeah. So now if agent is a generic commerce schema, okay, which can mean different things in different domains. Okay, an agent in final mile delivery or hyperlocal delivery might mean a delivery agent. Okay, an agent in mobility might mean a driver. An agent in healthcare might mean a doctor, right? Which means that there is a certain domain specific layering that has to be done on top of these core schema for domain specific implementations to actually exist. Okay, which means there has to be some context, there has to be some specification that defines all the domain specific layers, right? That variance across domains is defined using what we call as taxonomies. Okay, these define domain specific attributes to core schema elements. There's a particular nomenclature to all of these taxonomies, which is constructed out of a hierarchical sort of layering of scopes, like for example, domain level, network level, and then region level. So there are various taxonomies which are available in various regions as well. For example, say for example, one of the allowed modes of travel in India is a rickshaw, right? That rickshaw might not be available as a mode of travel in other countries. Okay, so similarly, these taxonomy layers allow creation of enumerations, enums, required fields. For example, in a domain like mobility, maybe a pickup location is enough for you to confirm an order. But say in a location in a domain of say hyperlocal delivery, a pickup location and drop location are required, right? Which means that these taxonomies must be defined very clearly for each of these domains, which tell you, hey, these are the required fields in the specification for this domain. These are the required fields in the specification for this domain, and so on, right? Similarly, allowed values and defaults, right? Which means that, say, for example, there is a field in backend specification called fulfillment type. Now, fulfillment type does not mean anything when it comes to very when it comes to domains, right? Fulfillment type actually describes how a particular order is going to be fulfilled. Now, that is going to be different again in various domains. Okay, for example, in retail, various types of the types of fulfillment involve, say, home delivery and store pickup, right? And when it comes to healthcare, the same fulfillment type might be teleconsultation or physical consultation, right? So, which means the mode in which you are actually fulfilling a particular order also varies across various domains, which means that there have to be enums and default values assigned to each of the domain-specific taxonomies, right? That will vary across various domains. And then there could also be domain, region, network-specific standards, which are also applicable at various layers. For example, let's see. Okay. So the commerce, say for example, the domain codes. Okay. Now there is a standard which is used. There's an India level standard which is used to assign codes to each of the various industry sectors. Right. One standard which we are using in backend is the National Industrial Classification 2004 standard, right? NIC 2004, which assigns 5-digit numbers to various standards. Now that could be a domain specific coding standard which is applicable only for India. Now tomorrow Europe or tomorrow the US might have a very different standards for assigning codes for each of these domain specific. I mean, I said domain, I'm talking about industry domains, right? There could be also region specific, there could be network specific standards, like say one particular network who has implemented backend protocol might want to use, say, standard international system of units, while the other might want to use the British system of units, right? So when it comes to measures, right? So those standards have now, and you'll see if when you actually read the specification, you'll not find anything specific to a particular domain, region, or network, right? So most of these will be available as a separate specification, which actually is going to be very soon API-fied, where one will be able to simply call an API to get the taxonomy rules for each domain, country, and network. Okay. So once you call that API, you can use that additional layer in your validation, API validation, to actually create domain-specific validation layers in your APIs. See. So so these are the domain-specific taxonomies. Okay. So till now we were just talking about the specifications and the API. Now, what happens when you actually implement the specification? What do you end up actually creating? Okay. For that, we need to go into the transaction layer. Okay. To understand the transaction layer, let me just take a quick step back and look at a very simplified diagram of a typical e-commerce flow. This is absolutely must be absolutely familiar to all of you, right? That there is going to be a buyer, there is a seller. A seller searches for an item. A buyer searches for an item. The seller responds with some matched items. The seller adds that item to cart. The seller recalculates calculates the quote, and then the buyer checks out the cart. The buyer actually returns the payment terms, and the fulfillment terms, etc. And then the buyer makes the payment and confirms the order. The seller actually, returns confirmation of the order. Then the buyer tracks the order. The seller also fulfills the orders. That's a very typical, it's a very simplified diagram of an e-commerce flow. Of course, there are a lot of more elements in that, but just to give you a sense of the e-commerce flow, right? This is a typical interaction in any. These are the typical flow of interactions in any e-commerce transaction.